I'm Peter Onufryk, and I'm going to deliver this year's NVMe State of the Union. So before we get started, let's take a look at the NVMe organization. The NVMe organization consists of 5 parts. We have a board of directors. The board of directors consists of 13 elected companies. You can see their names on the bottom. The role of the board of directors is to basically provide stewardship for the organization and set the direction. The chair of the board is Amber Huffman. Next, we have the technical work group. This is where a lot of the work, when you guys think about NVMe, is done. This work group basically does the NVMe standard. It does NVMe over fabrics, and I'm the chair of that work group. Next, we have the management interface work group. The management interface work group started off standardizing out-of-band management, but now it basically works on standardizing all NVMe management. I'm the chair of that, and the vice chair is Austin Bolin. Next, we have the marketing work group. The marketing work group is responsible for outbound communication, so things like maintaining the NVMeExpress.org website, webinars, blog posts, and so forth. The co-chairs are John Michael Hans, who's sitting to the right of me, and Cameron Brett. Next, we have the interop work group, or the ICC. The interop work group is responsible for putting together the test plans that's used for our compliance program. So those are basically the 5 parts of NVMe. So, a lot of you are sitting in the audience, you want to hear about NVMe, you think it's this new and up-and-coming interface. But the reality is NVMe has been around for a long time. In fact, 2019 is actually the 10-year anniversary of NVMe. So on this 10-year anniversary, let's take a look at some NVMe history and kind of how we got to where we are. So in mid-2009, there were a bunch of PCIe SSDs available on the market, but each SSD required you to load a proprietary driver. And we had the idea of, hey, we want to create an enterprise spec where you can just plug in the drive and it works, just like you do with hard drives. So we got together with a bunch of folks from Intel, Dell, and other companies, and decided to standardize what was then called Enterprise NVMe HCI. And the goal was enterprise features for PCIe SSDs. NVMe HCI was an interface spec that was done a couple of years earlier for NAND, and really the intent was we're going to take NVMe HCI, add a couple of enterprise enhancements, and that would be Enterprise NVMe HCI. So as we dug into that, kind of 2 things happened. The first is we realized we really didn't want to be backwards compatible with NVMe HCI. We redid the entire interface to make it high performance. The second thing is, digging into it, we realized that we wanted to address the entire storage market. We didn't want to build an interface just for enterprise. We wanted to build an interface that worked from client all the way through enterprise. In March of 2011, we released the NVMe 1.0 spec. At that point, it was called the Enterprise NVMe HCI 1.0 spec. And we got feedback that Enterprise NVMe HCI didn't really kind of roll off the tongue. We needed a better name. The second thing is, the word enterprise really didn't capture the goal of kind of having a common interface across all use cases. So we had a naming contest, and NVMe Express won. So now we have we changed our name to NVMe Express and NVMe. Soon after we released the NVMe 1.0 spec, a competing standard organization decided that they were going to standardize their own PCIe SSD interface. And interface wars began. A lot of things were said about NVMe. One of the things that was being said was that because it was kind of an industry organization, it was not an open org where people could contribute. It was kind of driven by one company, which actually was completely untrue. But to remove all doubt of that, we transformed the organization into a promoter org, which is basically the precursor to today's board of directors, to basically remove any doubt that it was an open org. In 2012, we created a marketing work group. We realized names like Enterprise NVMe HCI weren't really good, and we thought we needed some help with that. In order to gain acceptance in the market, we realized that we needed interoperability and quality. So we partnered with UNH IOL and created a compliance program. In 2013, we held our first Plug Fest. By 2013, NVMe SSDs were gaining traction, and what we saw is a number of OEMs developing proprietary out-of-band management interfaces. And we thought, the world didn't need a bunch of proprietary management interfaces, so we created the management interface work group to basically standardize NVMe out-of-band management. By 2014, we incorporated as a nonprofit with today's board of directors. Later in 2014, it was clear that NVMe won the interface war at that point. NVMe SSDs were becoming popular, and people wanted to scale the NVMe architecture and command set beyond what you could do in a server. So at that point, we had a standard interface for PCIe SSDs, and PCI is great, and you can build a fabric out of PCIe. But in all honesty, building a fabric out of PCIe is actually very technically difficult. And even if you can achieve that, you really can't scale it. So we started work on NVMe over Fabrics. In 2015, we published the NVMe over Fabrics 1.0 spec. We defined 2 transports, one for RDMA, which worked on things like InfiniBand, Rocky, and iWarp, and one for Fiber Channel. Later that year, we also published the first NVMe MI spec, which standardized out-of-band management. In 2017, we created the ICC, or the interop work group, to basically, we had a great compliance program going, but we wanted to get more members involved in making sure that we were focused on the compliance tests that the industry really wanted. So we created a work group to have members participate more deeply in that. And then late last year, we came out with a new transport, the NVMe over TCP transport, which I'll talk about a little later. So whenever you do a new industry spec, one of 3 things can happen. The first thing that can happen is you publish the spec and it can be stillborn. So what that I mean is, there may be a couple companies that build some prototypes, people kick it around, but it never really goes anywhere. So the spec kind of goes on the shelf. The second thing that can happen is you can publish an industry spec and you kind of get the early adopters and innovators using the spec. So there's some commercial activity, but it kind of gets stuck in this chasm, and it becomes a niche technology and never really takes off. And the third thing that can happen is you can actually cross the chasm and get widespread market adoption. I think that, when I go back to FMS, I know a couple of years ago, there were, we had people coming in and, NVMe was at the stage of, are we going to cross the chasm and become a mainstream technology? And I think that, it's clear that we've already done that. Today, NVMe is the interface of choice for high-performance client interfaces. We're also shipping a lot of units into cloud environments, not only in terms of shipping SSDs, but we've become the interface standard for storage. So if you go on a lot of hosted environments and you spin up a VM, NVMe will be an option for high-performance storage. And we continue to gain traction in our kind of core area that we started with, enterprise. Looking at the numbers, we have lots of companies shipping NVMe, and it's said that NVMe has become the new language of storage. So in the past, we had one language for client and a different language for enterprise. NVMe has unified that. So today we have NVMe, 23 companies shipping 96 models of NVMe SSDs, 13 companies shipping 93 models of servers that accept NVMe SSDs. So the success of NVMe is clear for PCIe SSDs. But not only that, we've also gained traction in kind of the storage array market. So we have 11 companies shipping 21 models of AFAs. We have NVMe appliances with 8 companies shipping 21 models. Adoption of NVMe over Fabrics has also gone very well. We have 5 companies shipping 53 models of HBAs and so forth. And we have 6 companies shipping NVMe accelerated adapters. So basically NVMe has crossed the chasm and is now a mainstream technology. I think the point where that became clear to me is I was on vacation in Washington, D.C. With my family. We're driving down the road. I see a billboard for a server company, and it's a storage server, and they've got like the big NVMe logo in the middle of that. So I realized that when I'm outside of Silicon Valley and I see the NVMe logo on a billboard, we've kind of reached mainstream technology. The numbers are also quite well, going quite well. In 2019, it's predicted that we'll ship 2.7 million units into enterprise, over 17 million units into cloud, and over 111 million units into clients. So I think that I hope to not hear like, hey, are we going to cross the chasm? We're across the chasm. We're the mainstream technology, and NVMe is the new language of storage. So with that introduction to the history of NVMe and kind of the market dynamics, let's focus on what happened this year. So as John Michael pointed out, we're on track to deliver 3 new specifications. In June, we delivered NVMe 1.4. In April, we delivered NVMe Management Interface 1.1. And we've released the NVMe over Fabrics 1.1 spec for 45-day review, and we expect to have a ratified version of that spec later this year. So 3 new specs in 1 year. That's actually never happened before. So a refresh of all of our specifications. The other thing that's still happening is PlugFest. So we had PlugFest number 11 at UNH IOL in June. Not only do we have a formal compliance program and integrators list for NVMe, we have a separate compliance program and integrators list for NVMe MI, and we're testing NVMe over Fabrics. This slide shows the specification roadmap. So we currently have 3 swim lanes. One for the NVMe specification. So the NVMe specification defines the NVMe architecture, the NVM command set, and it defines the transport binding specification for PCIe. So this was really the first spec that we came out with. The second spec is NVMe over Fabrics. So NVMe over Fabrics basically defines how do you scale NVMe over arbitrary networks. And again, we have 2 transport binding specs, well actually now 3, but initially 2, and then we've added NVMe over TCP. And then we have the NVMe Management Interface specification. So the MI spec basically initially dealt with out-of-band management. So basically out-of-band management is management that occurs outside of hardware controlled by the operating system. And there are 2 out-of-band management paths, SM bus and PCIe VDM. So that was in NVMe MI 1.0, and NVMe 1.1, we've now unified that, and the management interface work group is now working on all management of NVMe devices. So if you take a look at this roadmap, you see this thing on the right, the NVMe 2.0 spec, and it's kind of straddling NVMe and NVMe over Fabrics. I'll describe that a little bit later, but basically we're in the process of kind of reorganizing our specifications. So I'll give a little bit overview of that later, and then Nick will dive into the details of that in his spec when he describes work that's going on in NVMe 1.4. So there are a lot of great talks this year at FMS. We've got a talk that describes, a talk per spec that describes what's new in the specs. So I don't want to steal the thunder, of the speakers, but I'll kind of give you a brief overview of what's new in each spec. So in NVMe 1.4, there are 3 primary new features. The first is NVM sets and I/O determinism. Basically what that does is it allows you to partition traffic in an NVMe storage device so they don't interact with each other, and it improves quality of service. It's primarily intended for hyperscale applications. The second major feature is the persistent event log. You can think of the persistent event log as really a black box flight recorder for NVMe SSDs or NVMe storage devices. So, vendors have had logging capabilities in their products for a long time. What's unique with the persistent event log is that logging is now open. So OEMs or vendors can basically use that to figure out what happened when the drive failed. And then finally, we have multipathing enhancements. So multipathing has existed in NVMe for a long time. We introduced multipathing in NVMe 1.1. What's new in the 1.4 spec is that we've provided the hooks to basically choose the optimal path when you have multipathing. So those are the 3 new features in 1.4. In NVMe over Fabrics, there are 2 new features, or 2 primary new features. The first is enhanced discovery. Now we had discovery in the initial NVMe over Fabrics, but we wanted a discovery mechanism that could scale to thousands of nodes or more. And that's what we've done with the enhanced discovery. The second big new feature in NVMe over Fabrics 1.1 is the TCP transport binding specification. So, as I mentioned earlier, we standardized RDMA and fiber channel, which meant that we could run on things like InfiniBand, Rocky, iWarp, fiber channel. The challenge with all of those is that in order to run those, you need to buy special adapters and have special switches. Basically, with NVMe over TCP, you can now run NVMe over any network that supports TCP/IP, which is basically almost every network in the world. And the interesting thing is that, if you take a look at NVMe over TCP versus a Rocky implementation, so for Rocky, you may see a latency of like a 10 microsecond latency. It obviously depends on the implementation, but that's pretty normal. In NVMe over TCP, public numbers in the public TCP drivers that it adds about 20 microseconds. So that's like double the latency over what you can get with Rocky. So for some low latency applications, that's an absolute killer. But if you think about an NVMe flash-based SSD with kind of a latency of around 70 microseconds, you're talking 80 microseconds versus 90 microseconds. And the fact that you can do that now over any network without having to buy special hardware is a real advantage. So we're really excited about TCP. In NVMe MI, we have 3 primary new features. With the introduction of NVMe SSDs and the widespread adoption, we've seen people build enclosures. Enclosures need to be managed, and so one of the things that we've standardized is NVMe enclosure management. The second thing that we've standardized is what we call the in-band mechanism. So when we defined NVMe MI as an out-of-band management interface, we knew that there were some management capabilities that were defined in-band through admin commands that people wanted to access. So we provided a hook to allow you to, in out-of-band, to execute admin commands. So what people want is they want symmetry in their management. They want to be able to do the same things in-band that they can do out-of-band now. So what we've done is we've added the ability to issue management commands in-band through MI. And that's important for not only enclosure management, but it provides access to other services. The final thing that we did was storage device enhancements. So in NVMe MI 1.0, you need to manage something, right? You need to manage a physical thing. We call the physical thing an NVMe storage device. And in NVMe MI 1.0, an NVMe storage device consisted of exactly one NVM subsystem. So with the storage device enhancements, we can now manage storage devices that contain multiple subsystems, can contain connectors, so you can now manage an expansion card. You can manage switches on those storage devices, as well as I2C muxes and so forth. So that's a summary of what's new for 2019. Now let's take a look at the evolution of NVMe. So I like to think of this as NVMe as having kind of 3 stages of evolution. In the first stage, we were focused on how do we build a PCIe SSD with a standard interface. So it was all about getting NVMe adopted for PCIe SSDs, and it was about getting an NVMe driver in-box into all the major operating systems. I'm happy to say that we're done with that phase. So today, NVMe drivers are in-boxed in every major operating system, and you can see by the numbers that I showed earlier that NVMe SSDs are prolific. In the second phase of the NVMe organization, it was about how do we scale the NVMe architecture and command set over arbitrary fabrics. So this was all about NVMe over fabrics. And we continue to enhance NVMe over fabrics, but I think we're largely done with that phase. We have NVMe over fabrics, and it's being deployed, and we're basically, there's still work going on with that, as there also is with PCIe, but that phase is kind of done. So we're now in the third phase of NVMe, and there's kind of 2 pillars to the third phase of NVMe. The first is we're now standardizing new capabilities that are enabled by the fact that we're using NVM. So in the past, it was all about how do we build a better storage interface that kind of looks like hard drives but runs a lot faster. Now we're about using the new capabilities of NVM and standardizing the way to access those capabilities. So an example of that are zone namespaces, and there's going to be a great talk by Dave Landsman and company later on zone namespaces as an example of what can you do if you expose the characteristics of NVM and allow new use cases. The second pillar in phase 3 is new use cases for NVMe. So NVMe is used in storage arrays. You've seen that in the past. But we're continuing to add features to build out the storage array capability. We're also looking at entirely new use cases for NVMe, such as automotive. The thing about phase 3 is that it's highly speculative. So some of these initiatives will have market adoption and will cross the chasm. Some of them won't. So one of the challenges that we face is how do we deal with this with all of these new initiatives and the complexity that it introduces and allow people to execute NVMe without getting stuck in all the details of the use cases. So Nick will dive into the details of the spec refactoring that we're doing, but basically the goal is to kind of compartmentalize complexity so that if you're building a PCIe SSD, you can kind of look at the pieces that relate to you. If you're building a storage array, you can look at those pieces. If you're building a ZNS drive or a key value drive or using some unique NVMe over fabric transport features, you can look at the specifications that relate to that. And we recognize that this will allow us to innovate. We can now add new command sets. And if you're not interested in those command sets, you don't have to read those specs. If the command sets don't take off, they just don't get read. So we can basically continue our innovation without kind of burdening a single monolithic spec with all the details. So that's really the goal of spec refactoring. The other thing that we're doing is we're increasing the rate of innovation and improving quality. So you can't run a mid-sized company the same way you run a 50-person startup, and you can't run a Fortune 500 company the same way you can run a mid-sized company. Same thing's true for standards organizations. So we can't run NVMe the same way that we did when we first started. As the new language of storage, we now have a greater responsibility. We have OEMs and lots of manufacturers that depend on the work that we do, and we need to make sure that we continue maintaining high quality, and we allow people to innovate in the ways that they want to innovate. So we're doing a couple of things to address that. The first thing that we're doing is we're formalizing sub-teams. So we hold one technical meeting a week, and with all the things going on with new initiatives, we can't cover all of that technical material in that one single meeting. So we formalized sub-teams. So a sub-team is basically, you can think of it as a mini work group that goes off and tackles a specific technical proposal. But that mini work group basically acts like a real work group. They have to have a published agenda. They have a place in our members-only area where they can do that. They have to publish their meetings on the calendar so anybody who's interested can attend. They have to publish meeting minutes. So if you're a member, you can find out when the meetings are. If you don't want to attend the meetings, you can read the meeting minutes and find out what's going on. So that's the first thing that we've done. The second thing that we've done is we've improved the technical proposal process. So we now have 3 formal phases with explicit entry and exit criteria. And that helps us determine where are we in the development of these technical proposals and making sure that they're moving along properly and they have the right material for each phase that they're in. The third thing that we've done is we have an online document repository with revision history. So in the past, we've emailed around specs, and I'll be honest, some of that is still occurring, and I'm guilty of doing that. But basically, we're moving to the online repository, which is all the documents, not only the published specs, but everything that we're working on are available online. You can go in, you can look at the history, you can see what's going on. So no more digging through emails. The next thing that we're doing is always maintaining an integrated draft spec. So this sounds kind of like a trivial thing, but we had an experience where we had something like 20 technical proposals. We needed to push out an updated spec. And as we integrated those technical proposals, we found lots of errors. So we found that some of them reused opcodes, some of them updated text, and then other versions of it updated the same text in a different way. So there's a real difficult challenge in trying to resolve all those technical proposals. So now we maintain an integrated spec at all points every time a TP is done. As part of our release process, we integrate that TP into the spec and address any details right at that point rather than trying to deal with it all at the end. And the advantage is that if you're writing a new TP, you can basically pull up the integrated spec and make sure that your TP is updating the latest text. Finally, we've moved from in-workgroup meetings to weekly electronic ballots. As NVMe has scaled, we have companies that are participating in all aspects of NVMe, and it may be the case that the person that deals with the base specification or some aspects of fabrics is a different person that deals with management, and companies need to coordinate. So this weekly ballot allows them to do that offline in a week to vote. So in summary, NVMe has unified client, cloud, and enterprise storage around a common command set and interface. It is truly the new language of storage. The growth of NVMe adoption continues. I think we've crossed the chasm. We can see that the numbers are becoming very significant at this point. The NVMe organization has put in place processes and initiatives to support the increased rate of innovation and enable new NVM use cases. So we're now in this phase 3 of kind of real innovation on top of the NVM capabilities and entirely new use cases. So we kind of need to change the way that we're operating. Finally, as NVMe enters its second decade, we continue to maintain true our core principles of simplicity and efficiency. Thank you.